Okay, so let's have a look at example 1.39. So here we've got two lines and you can see that they're perpendicular to each other. All right, so let's have a look at the very first question here. So the diagram shows points P, 0, 2 and Q, 4, 0. The point M is the midpoint between. Okay, the line MN is perpendicular to PQ and meets the x-axis at G and the y-axis at N. All right, show that the gradient of PQ is negative a half. Okay, so we're looking at this part here. So just do the gradient formula here. So question A. So M of PQ is equal to, all right, so y2 being 0 minus y1 of 2 over 4 minus 0. So that would be negative a half. Okay. Question B. Find the point, find the coordinates of M. So for this one here, just do the midpoint formula, M. Okay. So we'll get a midpoint something. So the x coordinate of M is equal to, so add the x's together, so go 0 and 4. 0 plus 4 over 2. Okay, so we get 2. And then we get the y value of M. Okay, so we get 2 plus 0 over 2, so that would be 1. All right, perfect. All right, so find the equation of the line MN. Okay, so we're now looking at this. So we have the point M, we know its gradient, so we can just do our 1-point gradient formula. So I'll do question C up here. Okay, so let's just use the point M. So we have y minus 1 is equal to our gradient. Now the gradient is actually going to be the negative reciprocal. So because we have M, M1, M2 is equal to negative 1. So therefore, if the gradient of PQ is negative a half, so negative a half times M2 is equal to negative 1, times both sides by negative 2. So M2 here, or Mn, would be equal to positive 2. So I get positive 2, x minus 2. So y is equal to 2x minus 4 plus 1. So minus 3. So that is Mn. All right, question C now, D. So show that N has coordinates 0, minus 3. Okay, so that's just the y-intercept of that line there. Okay, so it's the y-intercept. So let x equals 0 and solve. So I get y equals 2 times 0 minus 3. So therefore y is equal to minus 3. So n would be 0 minus 3. Okay, fantastic. Question E, find the distance of NQ. Alright, so NQ, so that's going to be this line here. Okay, so we can just do the distance formula here. Well, you could actually, which is just doing Pythagoras' theorem there. So I'll have D is equal to the square root of x2 being 4 minus 0 all squared plus 0 minus 3 all squared. So I get the square root of 16 plus 9, which equals to square root of 25, which would equal to 5 units. Okay. So let's just write that in. Because as I said in the previous example, these things often end up being significant later on. So question F. So here we've got find the equation of the circle with center N and radius NQ. Okay, so that's going to be oop. Maybe I could do a better one. All right, so not too bad, but I might give up. So we've got N as the center and NQ as the radius, so it has a radius of 5 in the center of N. Now we can use our formula here of x minus h squared plus y minus k squared is equal to the radius squared. Now this is for the formula for a circle with a radius at hk, positive h, positive k. Now remember we had n as our center here, so I'm going to say will be x minus 0 all squared plus y minus minus 3 all squared, and we said that the radius was 5, so I get x squared plus y plus 3 all squared is equal to 25. Now, we could leave it like that, but we probably should expand it. So we get x squared plus y squared plus 6y plus 9 is equal to 25. Take the 25 over, so we'll get x squared plus y squared plus 6y minus 16 is equal to 0. All right, fantastic. So that's question F. Now, question G, hence. Okay, so hence always means that we're going to use what we just did. Show that the circle F, in F, passes through the point P. Yeah, I thought it might happen here. So that means that this distance here should technically be 5. Now, that would be a nice little check with our N. So let's look at our Y values, minus 3. Okay, and then the Y value up there is 2. Yeah, perfect. All right, so it does have radius 5, so we do know it will go through, but all you need to do is sub in the point P02, and it should work. So let's go G, so sub 0, 2 into that equation that we just had, and if it works out to be the right-hand side of 0 there, then we got the right answer. So I'll have 0 squared plus 2 squared plus, so I'm just going to look at, the left-hand side here. So 0 squared plus 2 squared plus 6 times 2, okay, plus 12 minus 16. So I get 4 plus 12 minus 16, which equals to 0, which was the right-hand side there. Okay, so therefore P02 lies on the circle. All right, so now let's have a look at question H. See how, it's always a nice question, the last one. Oh, rhombus. Okay, so the point R lies in the first quadrant, and P and Q are. Okay, so we have this new R is a rhombus. Find the coordinates of R. All right, so I guess we need to remember the coordinate, or sort of the properties of a rhombus. Now, a rhombus, okay, so R must be up here. A rhombus will have parallel, opposite sides are parallel. Okay, so that means that this would be parallel with this, and this side would be parallel with this side. So this side here would be the exact same side as this one here. Now, on the left here, we know that's a vertical line, and it's a vertical line of 5. So very simply, all we have to do is look at this point here and add 5 to the y. So it'd just be 4, 5. So H, okay, so R would be 4, 5, C diagram. All right, thanks for listening, and I hope you should be able to check your answers. So let's just go through the answers again. So for question A, the answer was -1/2. Question B, it was the point 2, 1. Question C, y equals 2x minus 3. Now that's in the gradient intercept form. Question D, 0 minus 3. Question E was 5 units. Question F, x squared plus y squared plus 6y minus 16 equals 0. G, was line P02. It does lie on the circle because it works out when we sub those points in. And R is the 0.45. You can see the diagram for that.